All right, so our topic for today is a continuation of Engineer Nika's discussion. So I will be focusing more on the implementation and solutions of the radio access network. Okay, so today we will be exploring these scenarios that's all too common no, for that is often overlooked. Okay, so imagine living in a place where sending a simple text message is a day's journey. Napakahirap, right? So where accessing basic healthcare information requires traveling to the nearest city. So last time, if you joined the ELS, one of the doctors to the barrio mentioned that before getting to the nearest hospital, it would take them around 1 hour or 2 hours from that barrio. So it's very difficult for them. No? So, for example, where the local economy is stifled, unable to connect to the broader market, so that's also a problem no, for farmers that they cannot sell their goods online. So this isn't a tale for a bygone era. So it's a reality for many in areas that has no cellular coverage. Okay, so I would like you to think of this area where you cannot find any cell site. Can you imagine any area na wala pang cell site? Can you mention a few if wala pa silang cell sites? Okay. Mhm. Bukidnon, okay, mostly in Caraga po for Mindanao, okay. So rural areas especially. So there's still a lot, no? So you are the subscribers that are really experiencing this kind of challenges. So we call it the connectivity challenges. And in the recent pandemic, we already realized that the lack of cellular coverage causes the following challenges. Ano-ano yan? No? What are those challenges? First is the economic impact. Okay? So imagine a small remote village like this that relies heavily on agriculture. So without access to 2G or 3G networks, the farmers cannot access online markets. So weather forecast or modern farming techniques. Probably the weather forecast would be coming from the traditional AM radio. And this lack of connectivity limits their crop yields and market reach. Hindi sila makabenta ng maayos. And directly affecting their income and the local economy. And we also experienced that during the pandemic, right? That having no coverage or very poor coverage give us a lot of frustrations. Okay? So cellular networks are vital for the modern commerce and information exchange. So without them, remote communities are cut off from the e-commerce platform, online banking, and global markets, so leading to economic stagnation. Next is the social connectivity issues. So in mountainous region, families are dispersed across difficult terrain. So the absence of, like for example, 4G coverage hinders communication, making it challenging for people to stay connected with distant relatives or access to social media. Okay, so social interactions and community bonds often rely on digital communications channels. So we all know that, no? So nakakapag-connect tayo sa Facebook, nakakatawag tayo sa Skype, right? Sa Messenger, because of the cellular connectivity. Next is the emergency services accessibility. So this is one of the important part as well. Consider a coastal area. Okay, malapit sa dagat, no? Prone to disaster, to natural disasters and lacking of 2G, 3G, or 4G coverage. So during a typhoon or a cyclone, residents cannot receive early warnings, nor cannot reach emergency services. So maliban na lang yung talagang radyo, no? Typical traditional radio, leading to a delayed response and higher risk of casualties. So imagine the typical AM radio is only simplex technology. That is only one-way communication. You cannot reply to that AM radio. So iba talaga if there is a cellular connectivity on that specific island. Okay? So you will have quick access to emergency services. That is very crucial. especially during these natural disasters or health crisis. And then lastly is technological isolation. Okay, technological isolation. So a remote town without 2G, 3G, 4G, or even 5G struggles to attract new business and young professionals. Okay. And kaya nagsisiksikan most of the professionals in the urban areas, right? And the lack of high-speed internet and modern telecommunications infrastructure makes it unattractive for tech-savvy individuals and industries. So the high-speed internet and advanced telecommunications are the backbones of the modern industries, including the tech companies, remote work, online education. So these areas without facilities will face difficulties, no, in keeping up with the technological advancements, leading to what we so called the digital divide. Okay. So these are the connectivity challenges. So imagine if we can connect, no, if we can connect these areas, no, with a cellular connection. So what can we expect in this area, no? So once we have built the cellular infrastructure in this area, so we can see that there will be enhanced communication and social inclusion, access to information and education. Okay, so this is very important, lalo ng pandemic, right? Economic empowerment. Okay, so the small business owner in a rural area who can transact her business using her smartphone. Okay, so she cannot only sell local products to her customer, but she can also reach other customers outside their village. No? So for example, merong isang teacher dito na she would like to have a small business about online tutoring. So you can boost that kind of local economy, no? If there is a connectivity in the area. Am I making some point here? Do you agree with with those some points? Especially it's for those areas na talagang hirap tayo sa connectivity. Okay. I'm just putting some salt, no, on those pain points because I believe most of our viewers right now or students right now are experiencing the same challenges. And then of course there will be an enhanced public services and healthcare. Okay. So this will improve the public services and healthcare delivery, especially in remote areas. So imagine yung mga remote doctors natin can already communicate, no, with their main hospital. And then kung meron silang mga kinakailangan na additional consultations or additional information, no, they can readily get that information. What else? Safety and emergency services. Okay. So, sabi ko nga kanina, doon sa mga disaster area, so we can get real-time updates. Okay, real-time updates, no? During this emergency and safety scenarios. And of course, yung IoT and smart technologies. So, para dun sa mga bago, IoT means Internet of Things. So, this is the kind of technology that almost everything that you can think of, you can connect to the internet. From the smartwatch, refrigerator, television, even your shoes or hat, no? Or even your sunglasses, you can connect it to the internet. Okay? So, so the development of the smart city where everything from the street light, traffic is interconnected. So that is what we call the IoT. Okay? So, um, um, bottom line, cellular connectivity is not just a technological advancement. It's a catalyst for social change, economic growth, and more connected, informed, and safer world. Okay, so we really need this kind of infrastructures, especially here in our country. That's why here in Asia Open Land Academy, we are driven by this mission to empower our future engineers, our current engineers, to build the skills and expertise in radio access network, particularly in Open RAN, right? So that you can also help in the development of our country because nothing will change if nothing will change, right? So you need the change must begin from within, from ourselves. So the change will start from building our skills and expertise. Okay. So we have this kind of technology already, right? So what are the different wireless technology solutions that we can think of, no? So as Engineer Nika mentioned, so this is the typical wireless telecommunication system. So we just have a recap. Okay, so you have the user terminals, the radio access network, and the core network. So sometimes we have two problem. Sometimes we don't have the user terminals. Okay, napakamahal ang user terminals minsan. And then sometimes we don't have a cell site, no? So that's a big problem. So in order for us to communicate end to end, we need to have these three, no? The user terminals, the radio access network, yung cell site, and of course connected to the core network. Okay? So, and also this evolution, this wireless network also evolved, right? So we started from 1G, okay? So 2G, 3G, 4G, and 5G, just to have a quick recap on this evolution. No? So later on, we will have a deep dive on each technology, no? Especially from the 2G, 3G, 4G, and 5G, because these are the current technologies that we are using right now. For 1G, we're not using it anymore here, no? Dominantly here in the Philippines. Okay? Okay. So I don't want to become more technical, but for those engineers, I need to show this network architecture evolution. So if you want to um, have a grasp of what's happening in the wireless technology in terms of network architecture. So for the network architecture, if you have the GSM, okay, so this the GSM architecture, you have the 2G, you have the voice, you have the PSTN network, you have the mobile switching center, the base station controller. These are the one that controls the base stations or the cell sites. And then um, you have this mobile station or the telepono. And then meron tayong data for connectivity, connected yan sa SGSN or the serving GPRS support node and GGSN, papunta sa data network. So kung tatawag ka, ang ruta ng tawag mo is dito, papunta dito. Kung ikaw i-connect sa Facebook, dito, papunta dito. Okay, that's how simple it is, no? Now for 3G, sorry no, medyo nagkakaroon ng problema tong slide. So for 3G, nagkaroon tayo ng bagong element. We call it the radio network controller, which is equivalent to base station controller. Yan. Palalabasin ko na lahat. No? Yan. Okay. Yan. So, meron tayong 3G. Okay. And then, nung 4G, nagkaroon tayo ng bagong core network. We call it the EPC or the Evolved Packet Core, which is composed of the packet data network gateway, okay, serving gateway, and the mobility and management entity for the control. And then ngayon, 5G era natin, for us to quickly deploy 5G, we did not employ immediately yung tinatawag na standalone deployment. What we implemented was the non-standalone deployment of 5G. What do we mean by non-standalone deployment? Non-standalone deployment means meron kang G-Node B, meron kang radio or baseband ng G-Node B, you will just interconnect it to the existing baseband unit ng E-Node B ng LTE and then connect it directly to SGW. Yan. So kaya ang tawag natin dito ay non-standalone deployment. So ang ating 5G ay connected directly sa ating LTE core network. On the other hand, meron tayong tinatawag na 5G standalone. So later on yung standalone pag-usapan natin. But to give you a brief introduction on the 5G standalone, meron siyang sariling core network. We call it the 5G core network, na yung 5G standalone. Okay, so this is the evolution that happens in our network architecture. Okay, so let's start with the 2G, no? So medyo mahano to, no? So every technology will have a glimpse of every technology, no? As I mentioned, we'll start on the 2G because this is the dominant technology that we are using. So the previous technologies, the 1G, I believe we are not using it anymore. So if you're asking what is the 1G technologies, ito yung mga amps, advanced mobile phone system, okay? TACs, and the NMT. Yan, ito yung mga pangalan ng mga first generation. Okay? Now, the second generation comes in. So, tinawag natin the global system for mobile communication. So, nagsimula ang GSM, It's a standard developed by the European Telecommunications Standards Institute or ETSI to describe the protocols for second generation. So naging digital yung ating networks used by mobile devices such as the mobile phones and tablets. So it was first deployed in Finland in 1991 of December, and this is the first generation replacement for analog cellular networks. Ito ay gumagamit ng circuit switch network optimized for full duplex voice telephony. Pag sinabi nating circuit switch, para kang merong hindi para ka, meron kang sarili mong circuit, no? Kino-close mo yung circuit, no, para makatawag ka. So kaya ang capacity nito is uh, hindi ganun kalaki, no, compared sa mga next generations like the 3G technology. This expands over time, okay, and include data communications. So nagkaroon tayo ng data capability using the GPRS. So ito yung kapag tumingin ka sa iyong telepono or mobile phone, you will see a G. If you see a G, that means you are using a general packet radio service, GPRS. Okay? And then if you see an E, okay, E, that means enhanced data rates for GSM evolution or edge. Okay, so GPRS probably it's around 20 kbps only. For GPRS, around 100 kbps to 200 kbps only. That's why sometimes it's very difficult to watch TikTok, no? If you are having a G or E in your mobile devices. And then later on magkakaroon niya ng HSDPA, H, or 3G, you know, that stands for the 3G technology. And then you have LTE, L, and then you have the 5G, you know, or 5G. Okay. Okay. So this is the GSM logo, and one of the challenges ng GSM is the frequency planning to avoid interference. Okay, so this is where the honeycomb was become famous, especially for students. So we are planning the different frequencies. So later na pag-usapan natin ito. However, in other countries, you will hear that the GSM was already discontinued. So pinutulan nila yung GSM. Among which are Telstra in Australia. So they shut down their 2G GSM network way back December of 2016. Tagal na, no? So they are the first mobile network operator to decommission the GSM network. Second mobile operator to shut down the GSM network last January 2017 was AT&T Mobility from the United States. Okay, followed by Optus in Australia. Okay, in 2017 as well. And then also in the same year, 2017, Singapore shut down the 2G services entirely. Okay, so in the Philippines, we don't know if what will be shut down here. Is it GSM or the UMTS? But let's wait, no, for that to come. But definitely, some of the technologies right now we are starting to decommission to give way for a more advanced telecommunication system. Okay. So ano yung mga GSM services natin? So if you will remember this, definitely you need to connect this radio access network going to the core network, and then you have a phone, and especially you need a SIM card, right? You need a SIM card. Okay. Okay. So there's a voice call, and outgoing calls, incoming calls, emergency calls. Okay. Data transmissions, so you have the GPRS, the edge, and short message service. So short message service is the technical term for text message. Yeah, so if you're a student or electronics engineering student, so you start using these terminologies already, no? So if you want to send a text message to your crush or loved ones, just ask your classmate, "Hey classmate, pwede ba ako maki-short message service sa'yo?" Yeah, using your mobile station. Yeah. So meaning you will be sending a text message using your classmate's mobile phone. So you feel the technicalities early on in your career. So short message service and using the mobile station. Okay? Okay. There are other supplementary services. We will not go through this one by one, but I believe you know this, especially for the call forwarding. If you're the type of person dati na you frequently your boss is calling you and then you put the call forwarding number of Jollibee. So when your boss calls you, uh, Jollibee is answering. Okay, so that's why a lot of engineers got fired that time. Okay, so don't do that now. Okay, that's just joke. Okay, so these are the supplementary services now. So if you look at the GSM architecture, sorry for making it more technical. So this is the GSM architecture overview. No, so you have three major divisions. So you have the mobile station, ito yung mga telepono natin. You have the base station subsystems or the BSS. Sa madaling salita po, this is the cell site and yung base station controller. And then yung NSS, the network and switching subsystem, which is what we call the core network, combined of the CS core, the circuit switch core, and the packet switch core. Okay? And then palabas yan, papunta na yan ng PSTN or local telephone line or internet service provider. Okay? Ayan. Okay, so ito yung ating GSM architecture. Okay? So before we proceed, okay, before we proceed with the 3G, no, I would like you to be aware as well in the multiple access techniques. Yan. So when we say multiple access techniques, so this is a technique which with the purpose to allow several users to share the resources of the air interface in one cell. Remember during the discussion of Engineer Nika, she mentioned about the spectrum, right? Spectrum, think of it as like yung sinasabi sa mga student for us for to easily visualize, no. Spectrum means it's like a highway, no. It's like a road. So for example, meron kang point A, okay, and then meron kang point B. In this example, the point A is your mobile phone, no, yung ating telepono. And then point B is our radio access network, right? Are you getting this analogy? I want you to remember this analogy, okay? I want you to remember this analogy. Although there are different analogies like waves, no, but this one, I think everybody can relate this because most of us are using the roads and highways every time, right? Spectrum is just like a highway or road, okay? So we transmit our data from point A to point B, just like flowing cars. Okay? So nagpapadaan tayo dito ng mga kotse, truck, okay, using the highway, right? Are you getting my point? Can I get a thumbs up if I'm making sense here? Okay? So use this analogy. So this is the electromagnetic energy, but this time we want to make it visible, right? Okay. So every highway is being utilized by different technology. So that's a spectrum. We call it the spectrum. And each spectrum, especially in cellular technology, is being paid by the operators. So imagine niyo na lang yung mga highway na yan is owned by different operators. Okay, so for example, ikaw ay Globe subscriber, so meron ka sariling highway. Meron ka sariling kalsada. Okay? Meron ka sariling RFID. Okay? RFID is your SIM card, right? And we know that in the Philippines, we have a lot of highways. For example, meron tayong mga different types of frequency, no? Meron tayong low band, okay? Meron tayong low band. Sorry 400. Meron tayong mid band. Meron tayong high band. Okay? Yan. So for low band, ito yung mga ating mga super highway. Okay, super highway. Super highway natin. So ito yung mga, for example, from Nueva Ecija going to Tugigaraw, yung mahahabang kalsada natin. Pero mga maninipis lang. Okay, so those are the low bands. Okay? So just put it in your mind, no? Na ito yung mga low frequencies natin. While the mid band, ito yung mga expressway natin. Okay, these are our expressways. What are those expressways? South Luzon Expressway, connecting Manila going to South Luzon. North Luzon Expressway. Ano pa? Can you type in? SCTEX, Subic-Clark, Tarlac Expressway. Right? TPLEX, Tarlac, Pangasinan, La Union Expressway. CCLEX, Cordova, I forgot the CCLEX. No? For those in Cebu area, just tell me. No? O, Cavitex, no? No, marami tayo. Cebu, Cordova, Expressway. Yan. So, ito yung mga highway, mga mid natin, mga expressways yan. Okay? So, nakikita nyo, tumataba yung lane natin. Ano? So, dumadami yung mga sasakyan na can use or utilize those frequency. Are you getting my point? So, the bigger the highway, we can say that this is bigger bandwidth. Mas malaki yung bandwidth. Eh ano naman yung high frequency, sir? Ano naman po yung ating analogy dyan? The best analogy for high frequency, because the performance of the high frequencies are, they have bigger bandwidth but short coverage. No? Maliit, maikli. So we can say this can be airport runways. Okay? Airport runways or NAIA runways. I get my point? Imagine how wide NAIA runway is. Kaya mo palipad ng eroplano. Magpalapad at magpalipad ng eroplano. Okay? I get my point? Okay, okay. So this is also one way of checking, no? Kasi you will see, bakit sa isang cell site, we can see a lot of antennas. Maraming antenna, may malalaking antenna, may mga maliliit na antennas. No? Why is it like that, sir? We will go back again, no, sa ating analogy of highway, right? So kapag congested na tong ating kalsada, what are we going to do? We are going to build another highway on top, di ba? Nakikita natin, nagpapatong-patong yung mga kalsada natin. Okay? So we need another highway sa taas. Kapag ka napuno naman to, nagko-congest na tayo, nagsisiksikan na tayo, no? Sobrang traffic na dun sa ating area. So we build skyways. Okay? We build skyways. So nagpapatong-patong na tayo. So this is the reason why you can see in different cell sites, we have a lot of RRUs, remote radio unit, we have a lot of antennas, and then we have multiple baseband unit. This is to cover the capacity requirement of the site, aside from the coverage. Okay? Gets po ba ito? Can I get a thumbs up if that makes sense? Especially sa mga non-technical people. Okay? Yan. So pag sinabi ng may interference, no? Pag sinabing may interference, imagine your highway, somebody is blocking, no? Blocking the flow of traffic. Merong isang nag-counterflow, merong isang malaking truck na bumangga, no? Humarang sa kalsada mo. That's why the traffic from your subscribers are not flowing smoothly. No? That's interference in the layman's term. Right? Okay. So now, what are these FDMA, TDMA, SCDMA, o FDMA? It's very technical, sir. Okay? It's very technical. So papaliwanag natin to how you will use your highways, no? Okay. So when we talk about frequency division, multiple access, each user is allocated a different subband or channel, right? Different subbands or channel. So imagine you have one highway, okay, and then you divide it into different lanes. Lane 1, slow lane, lane 2, lane 3, and then the fast lane. Getting my point? That's how FDMA stands for. Okay, so you divide, no, the highway. When we say TDMA or time division duplex, okay, so you open the highway in a certain specific period of time. Okay, so you can allow, for example, ginagawa to sa Cavite, right? So you stop at one point and then the traffic enforcer tries you to, okay, go, 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 go. And then stop. Okay, yung other side naman, go, go, go. So that's time division duplex. Okay. Now, code division multiplexing is another thing for example, if you are using the highway, and then these are coded, no? Coded. So, imagine as a coding scheme na ginagawa natin sa ating mga highways ngayon. Okay, so there are vehicles that can transport or can use the highway in a specific days, no, because there is a code that they are not allowed to use a specific channel so that they cannot transfer one person to another person. That's CDMA. Now, the OFDMA is another variant of FDMA. Okay, FDMA. But in this time, the allocated frequency are very narrow. Okay, masyadong masikip siya. Siksikan masyado siya. Okay. And then, a lot of transmission can be sent through that channel. Okay, just imagine yung mga sasakyan natin dito is somewhat overlapping pero hindi sila nagagasgasan. So, same thing pa rin sa OFDMA. And then, meron tayong, syempre, different timing. No? Different timing ng pagpapadala ng mga sasakyan doon sa from point A to point B. So, these are the different multiple access techniques that we are using in the cellular technology. So, in GSM, we are using the frequency division multiple access, FDMA. Okay, so what happens here is just like this. So the frequency is divided, okay, into different channel. Yung buong kalsada, we are dividing it in different channel. And then each channel has a specific bandwidth. For GSM, this is 200 kilohertz. Okay? So that is frequency division multiple access. Next is the time division multiple access. Time division multiple access, we give a time slot or frame, no? So for specific user to use the specific channel or road, no? Meron kang oras na dumaan diyan. May oras na bawal ka dumaan, may oras na pwede kang dumaan. Kung gusto mo, doon sa kabilang kalsada, what they're saying, no? So you can use this other kalsada at a specific time. Okay? So that you can maximize the use of the resource. Next is for the GSM, we are combining this type of time division and frequency division multiple access. So you can use different channel and you can also change the time. Okay? So we call it the frequency hopping in technology. So you can change the frequency or channel based on the plan of the engineer so that you can avoid interference, hindi kayo magbabanggaan, and you can also increase yung quality ng call. Yeah, that is what we call the TDMA and FDMA. Okay, so sorry for those engineers who are seeking more technical, I'm balancing the presentation because we are combined with some non-technical guys. So if you want to talk about this further, don't hesitate to reach out to me, and then we will discuss it on a more technical and deeper level. Okay, is that okay? Is that okay? Okay. Okay, so you can reach me in the Asia Open Academy anytime. Okay, all right. Now the code division multiple access, no. So this one I prepared a different scenario, no, a different scenario. So imagine if you're inside a room, no, full of different people, and these people are talking to each other with different language. Some are talking Tagalog, some are talking Bicolano, some are talking Cebuano, some are talking Hiligaynon. Okay, so if two persons are Hiligaynon, so they can speak to each other with a coded message. No, we call it the code. Okay, so even though we talk to each other at the same time, we can still understand each other because we know that the code that they are using is Hiligaynon. I can understand Hiligaynon. You experience this also when you are in abroad, right? If you are in a coffee shop in abroad, and then some people populating the entire coffee shop, and most of them are Americans. And if one person says, "Pare, pare, pare," you know that the code, that word is for Filipinos, right? Pare, pare, pare. So you know already that there's a code. Even though there is a lot of people talking, interfering your frequency or channel, because of the code, you can still understand. That's the essence of the code division multiple access. Even though there is a noise inside the channel, you can still understand because the mobile station, the user equipment, and the eNode B are talking on a different code. Okay? Ayan. Alright. Next is the orthogonal frequency division multiplexing. Okay? So we have the it's another variation of the frequency division multiplexing. No? Hinahati-hati rin natin yan eh. But the main point here is the design of the receiver. If you will see, the OFDM, the frequency division, no? The FDM, the frequency division, FDMA. The FDMA is yung hati na kanyang channels ganyan. No? From one lower band to upper band. Okay, so meron siyang ganyan. While the OFDMA, orthogonal frequency division multiple access, yung kanyang signal is like this. So yung upper point niyan, ito yung lower point, no, ng next carrier. Yan. Dahil sa complexity ng kanyang system, so you avoid the interference essentially. Kasi na-meet nung upper amplitude yung lower amplitude nung next carrier mo. So that's why we call it orthogonal frequency division multiple access. And the carrier bandwidth is only 15 kilohertz compared kay FDMA na 200 kilohertz. Okay, so again, if we want to talk this in a deeper technical detail, let's discuss it on other scenario. But for the meantime, for those non-technical, this is the difference of FDMA and orthogonal frequency division multiplexing. Okay? Okay. So GSM is using FDMA and TDMA. Right? Okay. Now, in our next technology, which is 3G, 3G will be using the WCDMA, the code division multiple access. Okay, so let's go to the UMTS now. Okay, wideband code division multiplexing or multiple access or WCDMA. So it uses a direct spread spectrum CDMA system. It's a user information, very, very technical discussion. 3.84 million chips per second. But what we are trying to do here is like this. Imagine you're eating a peanut butter sandwich. So what you do is that you will get the slice of tasty, no? Slice of gardenia tasty. Slice of gardenia tasty. And then you scoop a scoop of one peanut butter, spoonful of one peanut butter. We're not eating it, one spoonful of one peanut butter. What you will do there is to put the peanut butter and then spread it to the tasty. No? That's how CDMA has been doing. So instead of putting all the power of peanut butter in one small channel, we are spreading the power into the entire 5 megahertz radio channel. Okay? Nagutom biglang si Randy. Okay, so GSM uses 200 kilohertz. Okay, 200 kilohertz. Yan. While UMTS use 5 megahertz. That is 5,000 kilohertz. So there's a lot. No, so ganun ang ginagawa ng wideband code division multiplexing. Okay? And dito rin sa wideband code division multiplexing, this is the first time where we implemented two modes of operation. What do we mean by two modes of operation? We have two modes of operation. We have the FDD, which was already discussed by Engineer Nika. So we will just recap. You have the FDD or the frequency division duplex. So when we say frequency division duplex, we always remember that our telephone or mobile phone is communicating with our cell site. Hindi lang tayo ang tumatanggap ng tawag natin. That's the main reason why we can call. Because our phone is transmitting signal going back to our cell site. And then the channel that we are using, we call it the uplink. Parang kalsada ulit, no? So if we go for the kalsada analogy, kalsada analogy, we have the northbound and then we also have the southbound, right? I get my point? Uplink is the northbound from your mobile station going to the cell site. So that is the uplink. Now, there is another road going back, no? From your cell site, kakausapin ka naman ng iyong anong cell site, kakausapin yung telepono mo. And then your cell site is talking to you using this downlink channel. What is this downlink channel? From northbound going to southbound. Okay? So, ganoon naman yun, no? So, yung mga kalsada naman pabalik. Right? So, kahit na sabihin natin na this is GSM 900, there is a different channel. That's why if the RF engineer is good enough, he will learn that the frequency should not overlap so that it will not interfere with each other. Okay? So that is the TDD at the FDD mode. Gets mo ba itong FDD mode? Can I get a thumbs up if this makes sense? FDD. Okay? All right. So far, so good? All right. Next. TDD. TDD naman tayo. TDD is time division duplex. So what happens here? Meron lang tayong isang channel. Okay? So imagine this as the kalsada in Cavite. Andito yung mga motor. Okay? Andito yung traffic enforcer. Sabi ng traffic enforcer, "Oh, stop, stop, stop." And then papadaanin niya muna yung mga jeep dito or mga kotse dito. That's time division. And then after that, okay, kayo naman. Yan. Alright? So, it's easy to understand, right? If you use the analogy of road, especially for the time division duplex. So, we have these two kinds of modes. No? Now, 3G is the first technology that use this both FDD and TDD. Sir, sabay ba niyang ginamit? Hindi. Of course, it depends on the frequency. The frequency, the mode of operation depends on the type of frequency. For example, most of the low band frequencies like 400 megahertz, 700, 900, 850, 2100, okay, are FDD. Meaning, if you buy this to NTC, you will have a pair of frequency, uplink and downlink. Okay, do have different channel. Now for TDD, these are most common in the high band frequencies. For example, 2300, okay, 2500, 3500, okay, or 28 gigahertz to 70 gigahertz to millimeter wave. Kaya when you ask me, how can we select if we will use FDD or TDD sa aming network? Well, it depends on the current frequency of the operator. Meron bang frequency na FDD yung operator? Right? Baka kasi kapag pinilit mo siya, wala naman siya ibibigay. Right? Kasi wala siyang frequency pag-aari. Okay? Do you understand this? FDD and TDD? Before we go to the architecture of the WCDMA? Okay. Okay. Next, we go for WCDMA. So as you can see, it's almost the same, no, as the GSM architecture. You also have the user terminal or user equipment. Ngayon, ang tawag na natin sa kanya is user equipment. User equipment. Hindi na siya mobile station. Okay, sorry to say, no. You ask your classmate, "Can I borrow your mobile station so I can send an SMS, short message service?" Sasabihin ng classmate mo, "I'm so sorry, I don't have a mobile station. What I have here is a user equipment." User equipment is the term used sa 3G. Okay? Right? So that's a user equipment. So if somebody asks you to borrowing your mobile station and then you're owning a 3G, 4G, or 5G, we call it the user equipment. Okay? Gets ba yan? Are you getting the point? Okay. And then, ang tawag na natin sa ating mga cell sites or radio access network, we call it the UTRAN. No? Yan. So particularly dun sa equipment na nasa cell site, we call it the node B. Yan, node B. Hindi to katulad ng tawag natin sa base station natin sa GSM, we call it the BTS. Okay? Oh, BTS? Meron pala yan dati pa? Oo, dati pa may BTS na. Hindi nga lang kami nagkasayaw. No? Ayan. Ayan. No? So, BTS is Base Transceiver Station. Okay? So, once you complete this session, this first session, no, in our lecture, and then you go out, you go outside, you go to the mall, and then you want to eat something, and then together with you is your crush, no, or your loved ones, and then nakakita ka ng base station, no, ng cell site. Sabi mo dun, sabi nung isang kasama mo, "Oy, ang ganda ng base transceiver station, ang taas." Sasabihin mo, "Op, op, easy lang, easy lang, easy lang. It's not just a base transceiver station." No. Ang natutunan ko kasi, no, at sa pagbabasa ko ng mga white papers, white papers and deep documentaries about wireless telecommunication, it depends on the type of technology. If it's a 3G, we don't call it base station or base transceiver station anymore. We call it node B, right? Node B. If it's LTE, we call it E node B, evolved node B. And if it's 5G, we call it G node B. Okay? So don't call it base transceiver station. In fact, base transceiver station is very too old. Okay. All right. So you can use that also, no? You can use that. So you start to practice this kind of terminologies, even though it sounds funny, but it will help you a lot, no? Especially if you encounter this, if you are targeting to work in a telecom industry and then you are scheduled for technical interview. It's easier for you to speak those languages. Okay? So the core network is almost the same. Okay? So almost same, no? So it's just an upgrade of the previous technology. Okay? So 3G also evolved. So there's a lot of evolution happens in 3G. So in 2000, it becomes release 99. Okay? So the throughput of 3G goes up to 384 kbps only, up to from the downlink, yung download speed natin and the upload speed. But people are not very happy of the 384 kbps. If you have 384 kbps, how can I watch my crush TikTok? No, TikTok channel. It's too slow for me, right? And it's too blurry. No, we cannot enjoy so much of the educational content in TikTok, right? So I want more data. So sabi nung mga subscribers, because we want to learn more about this information and technology in TikTok, because most Filipinos are using TikTok, right? For learning, right? So we are using this for learning, and we broadcast a lot of in TikTok to teach people, to reach out to very sarcastic, to reach out to people and teach them, about this kind of technologies and how to improve their lives. Okay? Yeah. So the only thing is that I'm only wearing shorts there. DG. All right. Okay. So 2002, we become release 5. So you will hear the term HDPA, or the high-speed downlink packet access, right? So it goes to the 14 Mbps. So it's a big leap in the downlink. So from 384 kbps, it becomes 14 Mbps. And then we have this HSUPA. So there's an improvement. You can see 5 Mbps. Okay. So a lot of TikTok teachers here also. So yeah, educational content. Yeah, yeah. So you can just search the channel now. Okay. Yeah, there's an improvement in the R99, but the initial was a 384 as a practical. Yeah, 2 Mbps was the marketing on the marketing side. Okay. Release 7, release 8, release 9, and up to release 10. Okay, so those are the different speeds of UMTS. Okay. Okay. LTE introduction. Now, we move on to LTE. Okay, so LTE. LTE has a lot of things, no? I believe we cannot discuss a lot for LTE, but in the next sessions or in the coming sessions, we'll have a deep dive on the LTE. LTE means long-term evolution. Okay, it starts from 3GPP release 8. Okay, so meron tong flexible transmission bandwidth up to 20 megahertz. Okay, and the other technical specifications. So pag tinignan natin, you can see that the LTE started from 2008, and then LTE Advanced Pro, and then 5G noong 2020. Okay? And LTE also has different channel bandwidths. Ito yung naging maganda kay LTE, no? Meron siyang flexible channel bandwidths from 1.4 megahertz, 3, 5, 10, 15, 20. That's why you can see if you're working with a telecom operator or vendor, there's a lot of LTE bandwidth. So meron 20 megahertz, 15, 10, 5, 3, and 1.4. It's not like yung 2G. GSM is 200 kilohertz. Makita yan, liit, no? 200 kilohertz. Napakanipis ng kalsadang yan. Parang pwede lang dumaan dyan isang sasakyan. Okay, balikan. But the 5G, meron tayong 5 megahertz. At 3G, meron tayong 5 megahertz. Naging two-way siya. Okay? And then LTE has a variable, no? Pwedeng 1.4, 3, 5, 10 megahertz, 15 megahertz, 20 megahertz. Now, sabi ni Shannon, no, ni Claude Shannon, tataas ang ating capacity kung lalakas yung ating bandwidth, lalapad yung bandwidth natin. So, there's a limitation, no, for LTE. After 20 megahertz, what's next? Di ba? What's next? Kasi after 20 megahertz, hanggang 150 or 300 Mbps ang tayo. Papaano natin papaabutin ng 1 gigabit per second ang LTE? Diyan lumalabas yung tinatawag nating carrier aggregation. Okay? Carrier aggregation. So, may request ayan, sasabi niya, carrier aggregation. Pero carrier aggregation means we are combining different carriers. So, para tayong nagpadaan ng pinagtabi-tabi natin yung mga kalsada natin. Pinalapad natin yung kalsada. So, we call it the carrier aggregation. Okay? So, that is for LTE. And also, there's a lot of technology involved in LTE, no? So, LTE also use the FDD, the frequency division, and the time division duplex. And it depends sa available frequency, right? If you will ask me, what mode of transmission are we using? FDD ba or TDD ba? Okay? And then, it uses a higher order modulation. A higher order modulation is a QPSK, 16 QAM, and 64 QAM. So, that is the basic package ng LTE. Sir, napaka-technical naman itong QPSK, 16 QAM, 64 QAM. Ano po yan? Well, kapag QPSK, no, QPSK, you can transmit 2 bits per symbol. Ito naman, 4 bits per symbol. Ito naman, 6 bits per symbol. Ano yung symbol, sir? Imagine yung symbol ay sasakyan. Yan, sasakyan. Yan, sasakyan. Okay. So, di ba pinapadaan natin yung sasakyan sa kalsada, sa frequency natin? The 64 QAM, think of it as BMW. BMW, Mustang, Chevrolet Camaro, ano pa ba? So, yung mga sports car, yan, mga mabibilis, no? 64 QAM yan. So, saan natin ginagamit yung mga 64 QAM na yan? Ginagamit natin yan doon sa mga highways na malalapad, especially sa mga mid-bands, no? Sa expressway, TP-Lex, right? Are you getting my point? Because you can transmit fast, no? Yung BMW, mga sports car natin. Yung 16 QAM, we call it the, lagay na natin, no? Yung Vios, Mirage, Wigo, ano pa? Yan yung mga ano natin, ano? Ayan, so nasa mid-range, no? Yung speed niya mga yan. Okay, so kapag pinaandar mo yan ng mga 200 kilometers per hour, medyo nanginginig-ginig na yan. medyo nagwiwiggle-wiggle ka na dyan. No? So, hindi siya designed for that one, unlike the BMWs and the Mustangs. Okay? Ano naman po ito? Okay. Ang QPSK, ginagamit natin yan kapag ang ating mga kalsada o roads ay lubak-lubak, medyo challenging yung terrain. Okay? Alam mo yan? Medyo lupa pa yung highway, no? Yung road. Ayaw naman natin padaanin yung BMW diyan kasi sayang naman, di ba? Yung Vios, pwede pa rin pero sayang yung Vios, no? What we are using there are the 4x4 trucks. Yeah, ito yung 4x4 natin. Because 4x4 can travel using even on rough terrain or a poor environment or RF environment. That's why you can see kapag ka mataas ang interference, medyo malayo ka na sa cell site, masyadong mahina na yung signal mo, your system are using QPSK. Kapag ka nasa mid-range ka, for example, ito yung cell site natin, dito QPSK ang ginagamit natin. 4x4 track para kasi masyado na siya malayo, no? And then on this one, dito na lumalabas si 16 QAM, okay? And dito si 64 QAM. Yan. Yan. Dati kasi akong manok, no? Pasensya na kayo sa sulat ko. 64 QAM. Okay? So ito yung signal natin. Are you getting this point? This analogy? Are you getting this analogy? Okay? Can I get a thumbs up kung mali na yung analogy natin? So LTE uses that one. We call it the adaptive modulation encoding scheme. Okay, adaptive modulation encoding scheme. All right. And nagsusupport din daw ito ng multiple input, multiple output. Okay? Meron siyang MIMO, no? Multiple input at multiple output. Yan. So yung multiple input, multiple output, MIMO 'yon, no? Just imagine, dalawang sasakyan pinadaan mo sa dalawang kalsada. So, mas mabilis yung transmission kasi sabay mong pinadaan yung sasakyan mo, no? From point A to point B. So, yung MIMO, meron kang point A, meron kang sasakyan dito, meron kang sasakyan dito, meron kang sasakyan dito, meron kang sasakyan dito. Kung magdi-deliver ka, for example, ng mga gulay, 4 na sasakyan, alisin mo doon sa terminal para mas ma-receive niya na mas mabilis. Okay? That's 4x4 MIMO. Kung 2x2 MIMO, dalawang sasakyan, padaanin mo. Kung SIMO, isang sasakyan lang ang padaanin mo. That's how we use MIMO. Multiple input, multiple output. Using 2 or more, no, roads or highways to transmit data. Okay? Clear ba yung MIMO natin? And massive MIMO natin? Clear ba yan? Okay. So far, no? So far, so good. So far, so good? Okay. So, ang LTE nag-evolve din siya. So, maraming evolution sa LTE. Meron tayong release 10, release 11, release 12, 13, 14, hanggang dumating tayo sa release 15. So, maraming evolution bago tayo nakapunta pagdating sa release 15, which is the 5G. Okay? So, marami tayong evolutions. Pag-uusapan natin yung mga techniques sa LTE. Pero, I will discuss one particular example. Technology. The carrier aggregation. Carrier aggregation. Meron di ba, hanggang 20 MHz lang LTE. Carrier aggregation gives you the opportunity to increase your throughput para mas bumilis siya, no? So kailangan natin kailangan natin ng more bandwidths, no? So sa carrier aggregation may tinatawag tayong intra-band carrier aggregation. Okay? So magkatabi na frequency. So for example, channel 1, where is it? Yan. Channel 1 and then channel 2. So 2100 yan. Okay? So pagbalagyan natin to is 1800. Yan. So magkaiba silang channel. Ano? Yan. So carrier aggregation, intraband yan. Meron naman intraband non-contiguous. Pwedeng magkahiwalay pero nasa same 2100. Non-contiguous. Meron naman tayo na tawag na interband. Pwede natin pagsamahin yung 2100 at 1800. May 20 ka dito, may 20 ka dito. Essentially, 40 MHz yan. Okay? Sa release 10, hanggang 5 component carrier ang kaya natin. 5 carrier na tig 20. Hanggang 100 MHz yun. Sa release 11, 12, at 13, nakita nyo, 32 components. That is equivalent to 640 MHz. That's why kapag gumamit ka ng 32 na channel, na bands, umaabot ka ng 1 gigabit per second. Dito lumabas yung tinatawag nating gigabit LTE. Okay, finally, na-meet natin ang target ng LTE na 1 gigabit per second. Thank you po, carrier aggregation. Thank you, carrier aggregation. Okay? And then sa release 11, you can aggregate TDD. And then release 12, surprisingly, you can also aggregate TDD and FDD. Yan. Okay? Sir, pwede po ba yung i-carrier aggregation sa Wi-Fi frequency, ang LTE? Yes. Ang pangalan niyan ay LAA or License Assisted Access. Ang primary mo ay license, ang secondary is unlicensed. Ibig sabihin ng unlicensed, it's either 2.4 or 5 GHz. Ito yung ginagamit ng Wi-Fi frequencies natin. Pwede yan. Okay? Pwede yan. So, 2100 plus 2.4. Ang tawag natin dyan is License Assisted Access. So, gumana yan nung release 13. Okay? Yan. Okay? So, yun yung mga features ng ng LTE. Okay. So, sabi natin, ang LTE maraming pinagmulan. Basic LTE nung 2008, Advanced LTE nung release 10. So nakikita nyo, no? Not necessarily mayroon tayong target for a technology. Hindi agad yun mamimit on day one. There will be series of improvements. Katulad ng Android phone nyo, nag-update tayo ng software, right? Because there are improvements. Katulad ng mga iPhones, meron tayong iOS 14, 15, 16, 17, di ba? Nag-upgrade tayo so that we can also maximize because we are learning how the technology behaves on the actual scenarios. Okay? Okay. Basic LTE does not support voice calls but can go for CS fallback. Yan. Yan. Okay. So 5G is release 15 and release 16. So dumating tayo sa 5G. What is 5G, sir? Yan. Although meron tayong topic sa last session natin ng 5G, right? Meron tayong 5G mobile systems network. Okay, we will discuss this into detail dun sa discussion sa 5G on the 5th session, that is February 17th. So don't be okay mawawala dun. Okay? So, introduction to 5G muna tayo. So, ang 5G, pag tinanong ka ng 5G, kahit sa ang interview, any kind of interview, any kind of technical discussions, when somebody asks you what is 5G, ito lang yung sinasabi natin. 5G is the 5th generation, pang-5, no? 5, pang-5, 5th, and G means generation. 5th generation of mobile communication that uses new radio or NR. When you hear the term new radio or NR, we are talking about 5G. Wala nang iba. Okay? When somebody tells you that NR is 4G, mali po yun. So, NR is 5G. So, connected to a new 5G core network, ang pangalan ay 5GCN, and meron itong tatlong distinctive use cases. Okay? So, yung distinctive use cases is enhanced mobile broadband, massive machine type communications, at ultra reliable and low latency communications. Sir, ang lalim ng EMBB, massive machine type communication, ultra reliable and low latency communication. Malalim po. Enhanced mobile broadband, meaning ito yung high throughput natin. Umaabot tayo ng 200 Mbps, okay, 300 Mbps, 1,000 Mbps. Yun po yung EMBB. You get that? EMBB yun. Yun ang capacity ng 5G. Mas mabilis siyang dihamak kaysa LTE. Massive Machine Type Communications or MMTC. Tinatawag natin itong Massive IoT. Massive IoT. Internet of Things po ito. Itong MMTC. Kaya nating mag-connect up to 1 million devices per square kilometer. Ganyan kakalaki ang capacity ng 5G. 1 million devices per square kilometer. IoT devices. Massive machine type communications. Ultra reliable and low latency communications. Ibig sabihin po nito ay instant response ng network. If you are playing ML or Mobile Legends, napaka-importante sa atin, sa inyo, sa inyo, yung lag, no? Yung latency. Okay? Yung latency. Yung latency ng 5G is up to 1 millisecond. Ganyan kabilis ang response ng 5G. Okay? Kaya, using this URLLC, we can perform remote surgeries. Imagine, kung naglalag yung remote surgery, yung iyong doctor is located at the Singapore hospital and then you are here in Asian hospital sa Pilipinas, gumamit sila ng robot na 5G and then naglag yung latency, no? Hiniwa ka dito, no? Then suddenly, sabi ng doktor, ay nag-system time out. Saglit lang, magre-reconnect ako. Hold on, I will reconnect ha. Sorry. Sorry for the interruption. Sorry. Pangit yung internet connection eh. Ayan. Ayun, no? So, pagkabukas nung camera ulit, where is our patient? Nasa morgue na po. Sa morgue na po. Ayan. So that's how important URLLC. So this is one of the applications also in the driveless car, no? Autonomous vehicle. Okay? Because you are controlling the vehicle already remotely. Okay? So when somebody say, liko, 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 liko. Preno, 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 preno. Imagine if the latency is not so good, right? Sabi na kasing liko eh. Sabi na kasing preno eh, no? Yan. So we need instant response of the network. So that's the three major use cases of 5G. EMBB, Enhanced Mobile Broadband, Massive Machine Type Communications, at ultra reliable and low latency communications. All right? So for the meantime, that's what we will be discussing on 5G. So we can focus on the other topics now. And then we will dig deeper on the fifth session natin. Is it okay? Okay ba yun? Okay? Okay. Okay. So ngayon naman is pag-uusapan natin is how do we implement this, no? How do we view this, no, sa in terms of implementation? So maraming implementation strategies, no. So earlier, Engineer Nick showed you the different parts of a radio access network. Okay, so in this example, I will show you the different hardware components because software very very conceptualize yung pagpapinakita natin. So in equipment consideration, we have the antennas. Okay, so you will see this, the antennas. So the antennas are the one propagating the electromagnetic energy. Okay, parang flashlight. Yung flashlight natin, di ba may ganun yun? May parang conical. So consider that as antenna para ma-focus natin yung beam ng ilaw. Ilaw is a type of electromagnetic energy. Okay, magkaiba lang tayo ng frequency. And the frequency that the ilaw is using is synced to the optic nerves natin. Kaya nakikita natin yung type of electromagnetic energy. But the energy that the radio stations, the cellular networks are using is different, no? So masyado siyang mababa yung frequency so that our optic nerves cannot sync in. Hindi natin makita. That's why it's invisible. Okay? So ito yung ating equipment. Meron tayong antennas. Okay? So sa antennas, ang mga considerations natin dyan, mga electrical specifications, ano yung operating frequency bands, meron tayong gain, number of beams, okay? And then may mechanical specifications tayo. Ilan yung number of ports, dimension, weight, no? Para syempre, hindi bumagsak yung tower natin. Kinakailangan ma-compute yan ng ating civil engineer. Then after that, we will connect this antenna using a copper cable or the jumper cable. Ito yung traditional, no, na RAN, traditional RAN. So we use different copper cables. Okay, so kinokonekta natin yan dyan. Ito yun, ito yung mga copper cables na yan. So we call it the jumper cables. Ayan, ito yung mga jumper cables na yan. Okay? Okay. Okay, teka lang nagsulat siya. Okay. Next is jumper cable papunta ng RRU, remote radio unit. Okay, so yung remote radio unit, makita nyo, meron yung port. Kukonekta mo yung port dito. Okay, kukonekta mo yan. Kukonekta mo to dito. Yan, parang ganyan ang setup niya. Ano? Okay? Teka lang nakawala yun. Naka-annotate pala ako dito. Yan. So I will just remove yung annotation. Okay. So meron tayo dyan. Ano? And then, meron tayong CPRI, yung fiber optic papunta ng baseband unit. Ito yung ating baseband unit. Right? Yan. Okay? So ito yung ating components nung ano. So ang gusto kong tingnan nyo ito. Ang gusto kong tingnan nyo ito. Sorry. This one. How we are interconnecting this hardware component from antenna, cable, radio, baseband unit, and CPRI. Okay? Is it clear? Is this clear? The illustration before we proceed to the next slides. Clear? So, ganun ang logical connection yan. Antenna, jumper cable, radio, CPRI, or fiber optic going to the baseband unit. Okay? So, in the traditional implementation of the radio access network, when you say traditional, this is the current or the existing implementation. So, what we are doing, meron tayong 900 MHz na antenna, connected yan sa RRU na 900 at meron tayong BBU. Okay? Pag may 1800 tayo, 1800 yung RRU. Pag 2100, 2100 yung RRU. Simple, right? Now, there's an improvement happen. So, ito dati, for GSM lang siya, for GSM, and then for UMTS. Hold on. Okay. Now, there are RRUs already that you can see that can function in GSM, UMTS, LTE in different technology. Basta, same frequency band. That's why you can hear GSM 900, UMTS 900, LTE 900. Tapos isang RRU lang nakikita mo. Meaning, those technologies were activated in one radio unit. Is that clear? Clear ba yun? Same thing din pagdating sa 1800 at sa 2100. Okay? And then you can see only one BBU. Pinagsama na yan. So this will go to additional license and different boards. Okay? Ayan. The next, pwede naman natin siyang hiwa-hiwalayin. Ano? So dito, ang ginamit natin, meron tayong mga solutions or different types of solutions na yung tatlong technologies na to, pinagsama-sama natin sa isang type of antenna. That's why you can see a different antenna that has multiple ports. Umaabot sila up to 20 ports. Kasi pinagsasama-sama po natin dyan yung ating mga technologies. Yung ating mga RRUs, na 1800, 900, at 2100. That's why there are improvements that you can see. Okay? Do you get this point? So, hindi lang one solution, yung ating ginagawa. Ayan, tama si Randall, mixed mode ang ginagawa natin dyan. Okay? So, that's why you can see, there are cell sites na meron isang malaking antenna lang, and then there are cell sites also na maraming antennas. So, there's a possibility na mas marami siyang capacity or nagtipid sila ng equipment space. So that's one solution. Paano kung kulang yung number of ports? Pag kulang ang number of ports, ganito ang nangyayari. Yan. So gumagamit tayo ng tinatawag na combiner. Okay? So pinagsasama-sama natin yung 1800, most of the time high band, pinagsasama-sama natin yan, pinapasok natin sa port ng high band. Okay? So that's how logical yung mga sample interconnections natin. Okay? Does it make sense? Does it make sense? Logical lang po yung pagko-connect natin. So the reason why we are talking this, because when we go to the Open RAN, it could be the same scenario. So if you don't know the configuration, so you will be challenged, no? So kaya ano to, kaya sinama namin sa discussion. Okay? Now we want to compare. What is the difference, sir, of GSM, for example, 900 megahertz and 1800 megahertz? So ito, same parameter lang, nag-iba lang tayo ng frequency. 900 to, 1800 to. You can see, yung blue lang muna tignan natin, ano? You can see that the blue color is farther, kasi 2.7 kilometer yan by 3.2. It's farther compared sa 1800. Okay? That's why we are strategizing kung paano natin siya i-deploy. Okay? Now, this is GSM. Now, if you compare it to UMTS 900 and GSM 900, magkaiba rin po yung coverage niyan. Not necessarily same ang frequency. Pag magkaiba ng technology, magkaiba ng coverage yan. Dahil sa design ng power, output power niya. Okay? So magkaiba sila. So ito yung sample ng mga coverage natin. Now, if we go for 5G, kapag nag-implement tayo ng 5G, ganoon pa rin. So meron tayong mga existing components, katulad ng pinakita ni Engineer Nika kanina. So what we do for 5G is that we add this type of antennas, yung mga massive MIMO antennas, because these are important aspects of 5G. Massive MIMO antennas, additional CPRI, and then meron tayong additional baseband unit dito. Okay, so typical kapag nakakita tayo ng 5G, ganito po ang itsura niyan. Ayan. So meron tayong puting antenna mas maliit dito. Dito. Okay? Yeah, so we will discuss this further in the topics of 5G. Yan, ito naman yung sa 5G natin. Okay? Ayan. Okay, so yeah, that's a deployment, no? So if we have that kind of deployment sa radio access network, we can strategically plan where to deploy depending on the type of frequency, type of technology that the operator has at the moment. For example, this is the typical scenario for the rural, dense urban, medium urban, and suburban, no? So if you have the following frequency in this example and technology, so this is how we plan strategically. So the GSM, LTE 1800, located in dense urban and medium urban, followed by LTE 2100 and NR 3500. So example lang to, no? So it depends sa frequency ng operator. So kung mas marami silang frequency, they will have a different strategy. Okay, so typical for the rural areas like this, we are deploying this one kasi mas malayo yung nararating niya. Okay, so we have a strategy of deployment. Okay, clear po ba ito? Is it clear? Okay. All right, so now we're proceeding with the last few slides. No? So as you learn about the radio access network, we are not expecting you to become expert in one day, but we encourage you to slowly build your skill set in radio access network, especially if you're an ECE student and you're inclined towards learning wireless telecommunications. Why? Because there's a bigger purpose for you. There are people still in the Philippines that lack coverage. Okay? And being a future engineer in the future or a current engineer right now, people are waiting, no, for your expertise to be implemented also in this type of areas. Okay? So from this one, you can make a difference to make it like this vibrant community.